Example 3. The two lines L1 and L2 are given by these equations. L1 for the x component, 3 minus 2t, for y component, 1 plus t, and z component, 4 minus 3t. And for L2, x equal to 1 minus 5 plus t, y 4 minus t, z 1 plus 6t. And we want to figure out whether these two lines are the same, parallel, intersecting, or skew like this. That they are basically not parallel, but they are basically not intersecting neither. They're not intersecting neither. So the first thing that I do is to figure out the position, the direction vector. Here is the direction vector for the first one. What multiplies t? So L1 comes with our V1, which is -2, 1, -3. Then V2 comes with 1, -1, and 6. -1 and 6. Now, these two are not constant multiple of each other. If I go and multiply this one by -2, then the second one doesn't match. So not parallel. Now, the options remaining are either they're intersecting or they're skewed. How do I find if they're intersecting or the other way around? I have to find the point of intersection. If I find a point of intersection, they are intersecting. Otherwise, they're going to be skew lines, a pair of skew lines. And so what do I do? From there, basically, before going there, I know that there's a parameter t for the first one and parameter t for the second one. But the thing then to notice, and it is important, is that these parameters may not be the same thing. If the two of them are intersecting, there should be a value for parameter over here that gives an x and a y and a z numbers, and then another value for the parameter here that gives me x value, y value, z value numbers, that then the two of them are going to be the same. Because the t and t may not be the same thing, I have to name them different things. So I'm going to solve 3 minus 2t equal to -5 plus s. Give him another name for the parameter. And over here, 1 plus t equal to 4 minus s. And then over here, 4 minus 3t equal to 1 plus 6s. Then if this system is consistent and has a answer, then they are intersecting. So how do I solve this? First of all, I'm going to solve for s in here. So s is going to be equal to 8 minus 2t. Then I'll plug it back into here. And for s, I get 1 plus t equal to 4 minus 8 plus 2t. Therefore, t is going to be equal to -4 over here. Take it to the other side. T and 2t, and I get 5. And then this is putting it back in there. It gives me s equal to 8 minus 10, which is -2. Now, last step is, this is a system of 3 equations, 2 variables, and therefore I have to test the last one. So I'm going to plug it in. 4 minus 3 times 5 is equal to 1 plus 6 times -2, question mark, is it or not? And so 4 minus 15 is minus 11, and this side is -11 as well, so they are equal. So it's consistent. The answer basically is going to be achieved by plugging in either t in the first one, or t equal to 5 in the first one, or s equal to -2 in the second one. If I plug in t equal to 5, I get 3 times x is equal to 3 times 5, y is equal to 3 minus 2 times 5, and then I get 1 plus 5, and then z I get 4 minus 3 times 5, which the first one is going to be, the answer is 3 minus 10 is minus 7, and then 6 and minus 11, I think. Right? And so the point that I get, point of intersection, is -7, 6, and 11. And L1 and L2 are intersecting. Now, one extra thing that I want to add is that if you plug in -2 in the second line, then you get the same point as well. That's it.